Welcome to our channel. In this session, we will discuss some of the issues that occur in the design of code generator. So first I will list out all the issues and then we will move step by step. The first one is input to the code generator. Input to the code generator. Next one is target programs. Next one is memory management. And the next one is instruction selection. Next one is register allocation. And finally, evaluation order. These are the issues that may occur in the design of code generation. Now let us discuss one by one. The first one is input to the code generator. Input to the code generator. Here observe. So what is the input to the code generator? The code generation phase takes intermediate code as the output. You already know. First, we are providing source program to the front end. The front end produces the intermediate code. The intermediate code is optimized by the code optimization phase. And then optimized code is produced as input to the code generator. So, intermediate code is input to the code generator. Now, this intermediate code along with symbol table, the intermediate code along with symbol table information is used to determine the runtime address of data objects. You know that one. Symbol table consists of all the data objects along the addresses. So both this intermediate code along with symbol table, you are identify the runtime addresses of data objects. Now, how these data objects? The data objects are denoted by the names. The data objects denoted by the names in the intermediate code representation. It's common thing. Now, this intermediate code is represented in which format? Anyway, depending on your requirement, the intermediate code is represented in either 3 address code or represented in either a quadruple or represented in POSIX notation, or if you want to represent in graphical representation, abstract syntax tree or directed acyclic graph. So this intermediate code is represented in different notations. Whatever the intermediate code that is generated by the front end should be matched to the target mission, and that is manipulated in the target mission very easily, and then only the correct output is generated. The correct output is generated. Now, what is the need? What is the requirement? So, in order to generate appropriate target output code, the front end, what we are need to do? The front end, we need to perform type checking and type conversion. Simple point, in the front end of the compiler, the necessary type checking and type conversions need to be done. and also the detection of semantic errors should be done before submitting the input to the code generation. In the simple sense, the code generation needs a complete error-free intermediate code. This is the final agenda. Okay, what is the first point? Input to the code generator. So anyway, the input to the code generator is intermediate code. What is your aim? You need to generate an error-free intermediate code. Why error-free intermediate code? Why? Because so you need to identify the addresses of data objects. So how do we identify the address? The intermediate code information along with the symbol table. Anyway, these data objects are represented in intermediate code in the form of names. So, depending upon the representation of intermediate code, the corresponding output code is generated. This is the first phase, that is the issue related to input to the code generator. Now, second one is target programs. Okay. Anyway, the code generator takes intermediate code, error-free intermediate code as the input. What is the output? The output is it needs to generate one object code. It needs to generate object code or target code or mission code. This object code is occurred in three different ways: absolute code, relocatable code, assembler code. We already discussed it in the last session. So the object code that is generated by the code generator is absolute code or relocatable code or object code. You need to know advantage of each and everything. Depending on the target mission, we are selecting this one. What happened? Absolute code means the absolute code is placed directly inside the memory. Can be placed directly inside the memory. So, if it is directly placed inside the memory, executed immediately. Executed immediately. So, this absolute code is preferable for small programs. Now, this is the advantage if you are using absolute code. Next to relocatable mission code. What is the advantage of relocatable mission code? Subprograms. So if subprograms are compiled separately, subprograms are compiled separately, and then the relocatable object codes are linked and loaded for execution. Each and every object code generated for each subprogram, all those are linked and loaded for execution by using linker and loader. By using linker and loader. So in what situation this is advantage? If your program is divided into different number of subprograms. And third one, assembler code. The advantage is to generate the output process as easier. The code generation process is easier. It generates in the form of symbolic instructions, and it uses the macro facilities to generate the code. It uses the macro facilities to generate the code in the form of assembly language. So, these are the three different types of outputs, that is the targets that is generated from the code generator. Generally, among these three, relocatable mission code is the preferable target code. Okay. Now, input is completed, output is completed. In between input and output, the additional issues that may occur are: one is memory management. One issue that is faced by the code generator is memory management. What is the purpose of this one? Remember, both the front-end and code generator. What is the task? The task of mapping the names. Mapping the names in the source program to addresses to the data objects in runtime memory. This is the task. The task of either front-end and code generator is whatever the names that are available in the source program, that names are mapped to the data objects, the addresses where the corresponding data objects are present in runtime memory. So, the names that are used in the three address codes refer to entries in the symbol table. So go back to the previous session. You already know symbol table. What the symbol table consists of? The symbol table consists of simply the names that are used in three address code are placed as entries in the symbol table, and the type declaration statement. The type, we have different types of declarations. So the type of declaration statement decides the amount of memory that is needed to store the identifier. Simple thing. Symbol table consists of the names and which type of declaration statement you are using. We know declare an assignment operator, declare a increment operator, declare some statement. So different types of declarations are there. So the type in the declaration statement determines the amount of memory that is needed to store the declared identifier. So simple thing, using the symbol table information, we identify the memory requirements of the code generator. The memory requirements of the code generator, and also local variables. Local variables are simply some stack allocation in activation record, L global variables in the static area. All these memory requirements are done in the code generation phase. Now, the most important one is instruction selection. Instruction selection. What is mean by instruction selection? Simply selecting the best instruction will improve the performance of the program. So simply uniformity and completeness. Uniformity and completeness of instruction set is the main factor of code generator. The main factor of code generator. Now simply the selection of instruction depends on the instruction set of the target mission. For example, you are selecting one instruction. This is my target mission. So you are selecting the instruction that relates to this mission. Suppose you are selecting another mission, select the instruction related to this mission. You clear the point? So the selection of instruction set depends on the target mission. Simply the speed of the instruction, the mission items are the main important factors. Speed of instruction and mission items are the important factor for selection of instruction. And everyone remember, the selection mainly depends on the instruction set of target mission. Instruction set of the target mission. Okay. So, for example, just to consider one example, whatever the three address code that is generated. So, assume some statement x is equal to a plus b. X is equal to a plus b. How the code is generated in the sequence? Simply move a comma r naught, add b comma r naught. So finally move r naught comma some x. Generally, if this is the instruction, the code sequence is this one. So first loads the A2 register R0, perform addition between B and R0, and finally stores the content from R0 to X. This is the instruction symbol line by line. Generally, if you are generating such line by line instruction, it generates some poor code. There is a more chance of redundancy also there. Redundancy also there. Just for your understanding, I will write down one more example. Assume x is equal to y plus z. Some a is equal to x plus t. Assume this is my instruction. How do we write an statement by statement? Move some y comma r naught, add z comma r naught, and then move r naught comma x. So this is completed. And then again move x comma r naught, add some take variable c, t comma r naught, and then move r naught comma a. Okay. For this one, these three. So here, if you observe this one, there is some redundancy is there. Already r naught consists of the addition of y and z that is stored in x. Again, I am moving from x to r naught. So this is not required, and finally this is also not required. What I am doing, instead of writing redundant code, you can reduce the code also like this. Move y comma r naught, and then I am performing add z comma r naught, perform the addition, and then add some t comma r naught. Directly r naught consists of x value that is stored in t comma r naught, and move r naught comma a. See this one? Here what happened? You are reducing the instruction. Automatically the speed is increased and the number of instructions are less. The size is reduced and speed is also increased. Now you got it. This is the way to select the instruction. Whatever the instruction you are selected, that suitable to the target mission, that's suitable to the target mission. Now the next factor is register allocation. Register allocation. What is mean by register allocation? Simple thing. Suppose if the instruction consists of register operands, that is very fast compared to normal memory location. if an operand is stored inside the register, the efficiency, that is speed of execution, is fast. So compared to memory, register is very fast. That means the time of generating the good code, efficient utilization of register plays very crucial role. So while using register, you need to consider two important factors. One is register allocation. Second one is register assignment. You need to do these two activities while using register. Register allocation means we need to identify the appropriate set of variables that will reside in the register. For example, I have some 10 variables are there. Among the 10 variables, I want to use these 5 variables in the register. So, you need to identify set of variables that are placed inside the register. Okay. After identify the set of variables, then in the register assignment, you need to identify a specific register in which the variable will reside. Clear the point? First, you need to identify the set of variables, and after identify the set of variables, you need to identify the registers where the set of variable, where a particular variable is stored. Okay, that is the concept of register allocation and register assignment. Finally, evaluation order, the choice of evaluation order. So everyone know the evaluation order plays very important role while generating the target code. Suppose if you are doing one order, generates, it can use more number of registers, and it can generate multiple intermediate code. The multiple intermediate code, to store multiple intermediate, again to use multiple set of registers. Okay, so main thing is the order in which the instructions will execute. If you identify this order, okay, then the output is very fast. Simply for this, we can avoid this problem. Refer the 3 address code. Generally, if you are refer the 3 address code that is generated without any errors, if you follow that order, obviously the evaluation order performance is also increased. You got it? These are the different issues that are generated in the code generation. In the briefly, input to the code generator. Here we need to remember an error-free intermediate code as the input. Target, whether you need to produce absolute code or relocatable mission code or assembler code. Memory management, based on the information in the symbol table and type of declaration statement, we need to identify the amount of memory. Now, selection of instruction, that is small set of instructions without redundancy, plays very crucial role. Register allocation, identify the set of variables that are placed in the register and then identify which register is used for which variable. And finally, in which order the instructions need to be executed to get the more efficiency in the target code. These are some of the issues that are occurred during design of code generation. Thank you.